We have to be able to merge the concepts pertaining to the conservation of energy discussed previously with the concept of work. And a prime example of why can be seen on the screen right here. So let's assume we have a block. It's traveling with some velocity. It has kinetic energy. And then it slides onto a frictional section, and it slides all the way until it loses all of that energy, and that object has come to rest. We've all seen this happen anytime we've slid something across a table. If the friction slows it down, object ceases to move after some point. The problem with this is with our current understanding of conservation of energy. Well, we can define our 2 points. We could say 1 would be before it slides onto the friction. 2 is that point at which it's come to rest. So far, so good. We can go ahead and cancel out whatever energy forms we know we don't have. So initially, I have no gravitational potential because there's no height. I have no elastic potential. There's no spring. Afterwards, well, I still have no gravitational potential and no elastic potential for the same reasoning, but now I have zero velocity, so I also have no kinetic energy. So we wind up with a situation where the kinetic energy that I started with is just gone. It's just zero, which seems to violate the conservation of energy. We can't have kinetic energy just cease to exist. However, it did not just cease to exist. What we have to realize is as it slid across that frictional section, we probably produced a lot of heat. So if you touch the ground, it's probably a little bit warmer. There might have been some sound as well. Imagine, if you will, a car that suddenly slams on its brakes while going like 70 miles an hour. You're going to hear the screech of that tire as well. That sound is a form of energy. If you've ever seen tire treads kind of on the like skid marks on the roadway, part of that is because the tires heat up enough that the rubber actually starts to melt. So heat, sound, this is where the energy is going. So is it mechanical anymore? Is it potential or kinetic? No, but it didn't cease to exist. It's just in a new non-mechanical form. So the universe says, I don't care, I have the same amount. Before it was all kinetic, now it's all heat or sound, but the universe still has the same. The block doesn't, because the block's mechanical energy isn't conserved, because the energy just went to some other non-mechanical form. This is why we have to understand the idea of work in conjunction with the conservation. So just to adjust our equation, it's one extra step. Just like before, we have the gravitational potential, the kinetic, and the elastic potential. But on the left-hand side, if some work is performed between the before and the after phase, you have to add work on the before side. So the way we would read this as a sentence is the potential, the gravitational potential, plus the kinetic, plus the elastic potential energy that I begin with, plus any work that may occur, whether it be giving energy or taking energy away, that must equal whatever energy I end up with. So this really is the equation you've been dealing with the whole time when we did conservation. However, in our initial examples, there was no work. So you didn't realize it, but we were always plugging in 0 for work. Realistically, work is not always 0. This is a much more realistic representation, and this is the equation we should use moving forward. All right, we'll take a look at a few examples so you guys can understand how to work with this. No pun intended. And you'll see that if you're very careful and meticulous with your calculations and organizing your variables, this is not anything that is incredibly